Okay, so last video we finished off this exercise. Um, Sorry about the chainsaw noise. My neighbor is doing some work in his yard. Hopefully you won't be able to hear that too much. Okay, so what I wanted to do in this video is talk about doing some conversions into and out of formats that we're already familiar with. So for example, we can convert an nth order differential equation to a system of first order. So for example, here's our popular second order differential equation. And so I can convert that to a system of first order equations by making a couple of new substitutions. I can let u be equal to y, excuse me, and v equals y prime. And now our book actually just leaves the variables as y and y prime, but I think that might be confusing. Um, so, uh, or sorry, not the book, but the set of notes that we're using. The new system of differential equations we can just write down then. By the way, notice that the order here is uv. So u prime is first, v prime is second. And then when I write down my equations, I like to put u and v in order just to make sure everything is consistent. So notice that if I take u prime, that's equal to y prime, and y prime is equal to v. So therefore, my first equation is u prime equals v. Second equation, v prime equals y double prime, and y double prime is 2y plus, or 2y minus 3y prime. So that's by 2y minus 3y prime there. And so converting that into u and v then, that should be 2u minus 3v. And so therefore I have a system of two equations in my two unknowns. Good. So I can do that to an nth order. So here's a third order differential equation. So you might, oh boy, I shouldn't have had that milk in my coffee. Okay, let's see if we can get through this. So I've got the third order differential equation. I'm going to have three variables, u, v, and w, and so that'll give me a y, y prime, and y double prime. Notice that I can stop at the second derivative, right? Because one of my last equation is going to be differentiating w, which will be y triple prime, and so y triple prime I can write in terms of other variables. Okay, so let's write down the system of equations. U prime is equal to y prime, and y prime is equal to v, so therefore u prime is equal to v. V prime is equal to y double prime, and y double prime is equal to w, therefore v prime is equal to w. And then finally y I almost made it. Y prime is equal to y triple prime. I may have to redo this video. W prime is y triple prime, and so then I can solve for the equation. I'm going to be leaving cosine of t alone. Let's see what the equations then look like. U prime is v, v prime is w, and then w prime can be translated to 2uv plus cosine of t. Good. So I'm going to pause the video for a second and see if you can do this conversion. Oop. Okay, let's go ahead and go through the solution now. If I let u be equal to y and v be equal to y prime, then u prime is equal to v, and v prime is equal to, did you get 2u plus 3v equals plus cosine of t? I'm sure you did. Good. All right. Now, can we go backwards? Can I take a system of differential equations, first order, and turn it into a second order differential equation? It's actually not too bad to do that. So what we do is we take one of the equations, for example the first equation, and we solve this one for x2. And so x2 would be x1 prime minus 3x1. And so notice x2 is written all in terms of x1. Then you go to the second equation and substitute. So in place of x2 prime, we put x1 prime minus 3x1, and then we'll differentiate that, and then that'll be equal to x1 minus, and then substitute here. And so in the second equation we have two substitutions to make. In the first equation defines the substitution. Okay, so that's what we're going to do next. So let's go ahead and solve for x2 in terms of x1, and then we'll put it into the second equation. So x2 is x1 prime minus 3x1. Plug that into the second equation, and this is this is our x2 prime here, and this is minus x2, and now we just simplify. And so simplifying, we get this expression. We can continue to simplify and bring everything over to one side, and we get this expression for our differential equation. Now you might say, well, what happens if I had used the second equation and solved the second equation for x1 to be in terms of x2? Notice that you could have written x1 is equal to x2 prime plus x2. And then you could have gone up here and substituted in for x2 or x1. So in that case you would have substituted here and here, right? And then you would get a differential equation named x2. Would your differential equation be different at the end? Actually, you would get the same differential equation. So you might go ahead and just try that out. Again, that was use the second equation, solve for x1. So x1 is x2 prime plus x2, and then substitute that here and here in the first equation and simplify to see if you get the differential equation to be the same. Good. Okay, so that's converting systems. Oh, gosh, I've got one more here for you. Go ahead and press pause and give this one a try. Okay, did you give it a try? So here's the system of differential equations. We go ahead and solve the first equation for x2. That's x1 prime plus 2x1. Plug it into the second equation and simplify. Good. All right, so I've got another set of conversions that I wanted to talk about, which is more along the lines of a Calc 3 way of doing things. And so this is x prime of t equals a function of x and y, and y prime of t is an expression in x and y, and this is our autonomous system of differential equations, right? So this is autonomous because t does not appear directly. Well, in this case, there's a nice way of writing our differential equation. We might remember from Calc 3 that if I had a system of parametric equations like x of t, y of t, then you can compute dy over dx for the curve in the plane, right, that corresponds to this. And so what we found in Calc 3 is that dy over dx can be written as dy over dt divided by dx over dt. So that's like treating these as differentials, right? And so if we do that up here, what are we going to get? We can convert this system of differential equations to a single differential equation. And this is a differential equation of the form that we solved way back in chapter 2 at the beginning of the course. Okay, so let's give this a try, see how it works. Suppose x prime is y and y prime is x. Can we use our technique to find dy over dx and solve it? Well, dy over dx is, go ahead and put it as dy over dt over dx over dt. So that would be minus x divided by y, which is what we have here. And this is a separable differential equation from chapter 2. And so we can multiply both sides by y and dx and get this expression. And now we just integrate both sides. And now I can simplify this by bringing the x squared over to the other side. And then I multiplied everything by 2 to make it a little bit simpler expression. And this we recognize as a circle. And so our solutions then in the plane for this differential equation are going to be circles of some fixed radius. So given a starting point, right, in the plane you're just going to be seeing the circle. Okay, so what this does not tell you is which direction the curve is traveling around the circle. Is it traveling counterclockwise or is it traveling clockwise? Okay, we could probably tell from this, but you can't really tell from this because we're removing time from the equation altogether. So the time direction is missing from this, but this is a really good description too. Good. All right. And we can check, just to do a little bit of Calc 3, we can differentiate that with respect to x. This is implicit differentiation. Do you remember that? So y squared is, when you differentiate this, it's going to be a chain rule. So it's 2y times 2y is the derivative of y squared, but then you have to multiply by the inside function, which is our y. Okay, that's dy over dx. Good. All right. So that's it for now. We have how many different ways of doing conversions? We can convert an nth order differential equation to a system of first order. We can convert a system of first order to a second order differential equation. And finally, we can convert uh, a system of autonomous differential equations to a single first order differential equation. Good. And so I'll give you some homework problems to practice with those, and I'll see you later.